Welcome to the t-test tutorial. Today we're going to be focusing on the in-class assignment, the third week in-class assignment for ECG. And one of the cases that we have is that we have monitored two individual patients that have slightly different mean electrical axes, and we're trying to figure out whether they're statistically significant from a few factors. The first test that we need to perform is basically whether I can conclude that the patient one's mean electrical axis is truly higher than 90 degrees. And in this case, I am definitely comparing means, but the question is, which test am I comparing? If I'm comparing means, I'm comparing a sample versus a single value. This hopefully should be a reminder that we're going to be running something. I'm not going to tell you. It is part of the in-class to figure out which test that is. So that is one test that we have to perform. And then the second is what kind of statistical test is needed in order to conclude whether patient one's mean electrical axis is different than patient two. And I run a second test. So what I'm going to go ahead and do is I'm going to run multiple tests. This one probably is going to be a little bit more telling when I run the tutorial, but the other one, I think I want you to think about a little bit from the test that I'm going to run. So I have my data set up in this way. Sorrowfully, SPSS needs to configure the data differently for different tests. So what I'm actually going to go ahead and do is I am going to go ahead and copy everything and paste with variables. And something that I want to go ahead and do is perhaps go here and delete these just in case. Well, let's hope that works. We'll see. So the first thing that we can do is compare means, and then we have our t-test, which is also a spoiler for what we're going to be doing. So I'm going to go ahead and start with a one sample t-test and check what does this t-test ask me to do. Well, let's say we compare patient one, and the test value, it said, is 90. If we go back to the in-class, it is asking us, not that one, it is asking us if it is higher than 90, and that is in itself a keyword. I'm actually going to go ahead and bold for your guys' benefit. I'm going to check the options, nothing there, and I'm just going to go ahead and click OK. And here I see the patient one. This is the mean, standard deviation, standard error mean, and then this is the one sampled test. So it's comparing whether my little bag is different than 90. And I have the significance, but it's giving me the significance of one-sided or two-sided. So the question is, which one is right? It is the same number. It doesn't mean that it will always be the same number. So which of these two it is? And that is why I highlighted that keyword, higher than. So it means that directionality matters. The way in which the significance is pointing matters. Therefore, it means that I am going to pick the one-sided p-value because it's higher than. So in this case, for comparing to the 90 degree separation or 90-degree deviation compared to what the subject had, this happened to be significant. It is statistically significantly different than 90, and in this case, it is higher than 90. That's what that means. For the second test, as I get back to my thing here, it is asking, well, patient one and patient two. And we have to think about that. Okay, so we're comparing two samples. Now, are they independent samples or are they dependent samples? Now we're looking at patient one and we're looking at patient two. So there's two individuals that I am trying to compare. Spoiler alert. These are independent samples because the patients have no relation to each other. There are no time samples, meaning patient one before or after a certain intervention, or patient one with certain treatment and patient one with another treatment. So in that case, we would be still comparing means, but it would be independent samples. And in here, what we need, we're testing this mean electrical axis. And for the patient, is going to be a grouping variable. And then I need to define the variables. So it's going to be group one, group two, continue. Okay. And then we have here, presuming equal variance, we have that in this case, we're only caring about the difference. If I am not mistaken, it's truly different, which means that sidedness doesn't matter. So it means that we take the two-sided p-value. Now, if we were to be comparing patient one before and after, or patient one, condition two, then we would be using the paired t-test rather than the regular t-test. So that is all what I have for this particular tutorial. So we'll see you in class. If you have any questions, let me know.